your math can suck as long as you have the class checking you. So this is why I love sending you home with assessments to do. Work with each other, catch each other's math mistakes. That's kind of the point. I'm not testing you on how well you can add and subtract. I'm testing you on what you do with it once you have it. And right now, I want you to check your data and see how much of the data falls between these two numbers. Let's check it. Fingers. My toes aren't talented enough. I need you guys. I can't lift my toes one at a time to count. We have a second for 19? 18? 18? 19? 18? Hey, even if we're off by 1 or 2, isn't 18 roughly half of 35? Boom. It's not going to be perfect, that's why I use squiggly equals. Squiggly equals, squiggly equals, approximate. The only way those numbers are going to be exact is if you have a perfect bell curve in front of you. You will never have a perfectly bell-shaped distribution in the world, ever, except in math classes. And this is not a math class, it's a stat class. You're always going to have bell-ish curves. But the point is that roughly half the data is in there. Roughly half the data. So depending on how wide you let your ruler go, you're talking about a fixed percentage of what's between your two ruler ends. The further out you go standard deviation-wise, the more data you're trapping. Why would we even care about this? Why would we care about this?
That's a good question.
That's a really good question, isn't it?
Yeah.
What did I start this whole example asking? This whole example was based on weight loss data, yes? What were we trying to decide about this weight loss? What was the very simple question it all started with? Right, how much did we lose? Does it work and how much did we lose? Well, now you can assign a probability to it, can't you? You can say it looks like there's about a 50% shot, 50% shot that you're going to lose somewhere between 4 pounds and 26 pounds. You see what I'm getting at? You can now assign a probability rather just an average. Isn't that powerful? You see, you might not be excited about it as I am. I'm stoked. We're starting to see our first fusion of probability and statistics. Please. Oh, I thought you were going to say, I'm sorry, I saw a hand and I saw a nodding. I thought I was like, yeah, now I'm into it. Exactly, you're into it. It's freaking rad. Because now you can fuse the two things. Your stuff from your first project plus statistics are shaking hands. What's the big if, of course? The big if is that you have bell-shaped data, right? That's the big if. Sometimes you don't. Sometimes you don't get the benefit of bell-shaped data. So if you don't have bell-shaped data, we'll deal with that momentarily. I want to deal with bell-shaped data first. Any questions you guys have on this? It's a lot to process, of course. Any questions you have right now? I love your response. It's a good question. Why do we care? Because you can fuse probabilities with it now. Go ahead, Kelly.
So you're saying, if you can put all this data into a bell shape, if it winds up looking like a bell shape.
Can I edit that statement real quick?
Huh?
Can I edit that statement real
Yes.
quick? If the data is bell-shaped, not if you can put it into a bell shape.
That's what I meant.
Okay, good. As long as that's what you meant.
Yeah.
I started having nightmares of Harrison Ford running from the guy trying to kill him because they're messing with the data. You don't want to be Harrison Ford in The Fugitive. Running away from the dudes trying to kill him because the guy messed with the data. You don't want that. Okay, go ahead.
No, don't want that. Okay. You're saying then, pretty much, there's a 50% chance of the question, at whatever the question is.
Well, the statement was there's a 50% chance that you're going to lose between 4 and 26 pounds.
Okay.
But you have to have, see, generally, you're going to have data put in front of you.
Right.
You're going to look at the data and go, oh, look, it's bell-shaped.
Yeah.
Then once it's bell-shaped, you're going to have these two measures of that bell. Now, we did it a little bit backwards, didn't we? We found those two measures first and then graphed the data. In general, you're going to graph the data first and then decide, okay, now I should take the average of the standard deviation. Now I can use it. But once you have it, you can then apply those percentages to those little formula that are over there, x bar plus s plus 2s plus 3s plus or minus 2/3 s,
Yeah.
and apply the probabilities to them. And that's what those p-values less than 5% are doing. They're saying less than 5% of the time you're going to get data outside, which means greater than 95% of the time you're inside. So that's, yeah, you have to have the average and standard deviation first
Okay.
before you can apply those measures to them.
Okay.
Does that make sense?
Yeah.
We did do it a little bit backwards today. Generally, you don't do the graph second and the measures first. You do the graph first and go, okay, it's roughly bell-shaped, now I trust the average. Now I can go. Fair?
Yeah.
Good, Zach, go.
So it's kind of looking backwards.
Yes, yes, yes.
Now, if you wanted to fit a deviation that is 5%, you just take the number, find out what 5% of it is, and just knock off your outliers and just go.
What number are you talking about?
Like whatever, 35. And then find out what 5% of 35 is.
What assumption are you making about your data?
That is bell-shaped.
That it is bell-shaped,
So
yes.
already
But you'd
established that.
have to knock, I like what Zach is saying. He's saying, wait a minute, can we just knock off 5% of our data? You'd have to knock off 2.5% on either end, wouldn't you? Because it's a balanced 5%. It's a 5% total area. Some are below, some are above. But yes, especially for large data sets, it'll work just fine. But the question is, what does knock off mean? I cavalierly said, talking about your outliers, getting rid or chopping outliers, they're not always chopped and gotten rid of. They are a happenstance of probability. They do happen. I mean, you end up with 7-foot tall people sometimes. And you end up with 4'8" people, full-grown people sometimes. You don't chop them and throw them away. Maybe you ask why they are that way. Oh, it's genetics, or oh, they drank too much Delaware water, or something. You know, something along those lines. So you don't always throw them away, but yes, you can ID them that way, at least in general, in the very general way. Good. Speaking of heights, I've always been interested in this. I was told that heights are bell-shaped. So I decided to see, and let's just play. I've collected some data. I want to collect your data too.